Wherever you might be. This is Frederick Winsness with NetHope, and we'd like to welcome you to another NetHope Solutions Center webinar. Today we get a chance to hear about from flights to maps, humanitarian drone applications with Esri and Drone2Map. This is actually a review of the session, the field visit that was actually done at the NetHope Summit in Puerto Rico back in October. And in full disclosure, that picture is not from that particular session because that day it was raining cats and dogs in Puerto Rico. But anyway, I think this is going to be a very, very interesting review of what took place back then. So before we get started, let's go over some housekeeping information. We want this to be as interactive as possible. You as attendees cannot come off mute here, so please post your questions in the chat window, and we will collect those and have a Q&A session at the end of the session today, last 10-15 minutes or so. We're recording the session today, so you'll see a follow-up email with links to the landing page for this webinar, and the recording and the collateral, the slides will be there as well. And if we don't get to answer all your questions, we may have a Q&A document posted as well. And at the very end, you will see a webinar satisfaction poll show up in your browser. So if you could take a couple minutes and answer that for us, that'd be very helpful for us to keep improving this webinar series as we go forward. So with that, I want to introduce our speakers today. We have Andrew Schroeder from Direct Relief. He's the Vice President of Research and Analysis there, and he's an old hat at these webinars. I think this is, yeah, I don't know. I don't even have the count, Andrew, how many webinars you've been doing for us. So thank you very much for your support. We also have Eric Lowell from Esri, and he's the account manager for the nonprofit and global organizations there. So welcome both of you, and I'm going to turn it right over to you, Andrew, and I'll be back with a Q&A session. So over to you.
Great, thanks, Frederick. Do I have control on the slides? Do you want to go forward?
You just need to share, Andrew.
Oh, I just need to share my screen.
Yes.
Okay. 1 second. Oops. Incorrect. Sorry, I thought this was already loaded up on your end. Okay. Thanks. I'm going to talk a little bit about material that we went over in Puerto Rico, like Frederick said. It was a nice sunny day, and then it turned into a quite rainy day. Fortunately, we had tents originally to keep the sun off our heads, and then to keep the rain off the equipment and ourselves. But it was a well-attended event, and I think there's been a lot of interest in this topic. So we thought it would be useful to kind of go through some best practices and case studies, and then some resources for helping kind of organize how folks are thinking about this, and then hand it over to Eric to go over some workflows in Esri for getting data and other kind of analytical value out of the maps that you produce with drones. Just a little background on my own work with Direct Relief on this. We've done a lot of work on testing of drone delivery in Puerto Rico and in the Bahamas. And I'm also the co-founder of We Robotics, which focuses on localization of capacity for drone mapping and other robotics applications, which is important, particularly in the case of humanitarian drones, because of the need for local knowledge, being on site, familiarity with the issues and the regulations of the places where we're working, where humanitarian crisis occurs. So the flying labs are distributed around the world, and our local partnerships aimed at building capacity to do this kind of work and to be ready when humanitarian crisis happens. So you can follow up at werobotics.org. just wanted to quickly go through a couple of case studies of what I think are some of the most interesting recent best practices in humanitarian applications of drone mapping. Two of them in particular in Bangladesh and Mozambique. One is a piece of work that was done by the International Organization for Migration, and I've just been, this is a very impressive project and a really good example of how to get analytical value and humanitarian program value out of drone mapping. The problem was essentially that this particular set of settlements expanded extremely rapidly in areas that were very risk prone in a number of ways. There was very little known about kind of this landscape, and IOM took the opportunity to begin doing extremely accurate and extremely granular time-sensitive maps, so repeatedly over time to look at the growth of the settlements. The process, sorry, excuse me. Yeah, sorry, these have audio associated in here. In this case, the drone imagery was extracted into OpenStreetMap basically by connecting directly with the OSM editor. So basically tracing areas in the OSM editor that could then be turned into vector imagery, vector data, and then uploaded into HDX. So the maps in HDX, as you see here, the that are downloadable as shapefiles now, are derived from drone imagery and are shareable, you know, in relatively low bandwidth settings, given that it's not the imagery itself, it's the footprints from the settlements. So that's been, I think, really valuable for a number of people to be able to look at the growth of the settlements, to do humanitarian planning, et cetera. This really wouldn't have happened without being able to run, in this case, they flew EBs, which are fixed wing aircraft able to cover a pretty broad range of territory and at high resolution. So I believe 10 centimeter resolution was what was collected here. The second is one that I was at least initially involved in the cyclones that were that hit Mozambique earlier in 2019, between March and May of 2019. In this case, we had done preliminary work through We Robotics to help train INGC, which is the disaster management agency of Mozambique, in data coordination. They already had actually a drone mapping team that's quite talented that had been supported with equipment by UNDP. And with some licenses of Pix4D to be able to do the mapping. They, in our case, we were looking at implementing coordination structures so that this could be done cross-organizationally and data sharing can flow in the field based on a flight workflow related to extracting vector data and then connecting that into local teams that would be doing the support in response to damage that occurred as a result of the cyclones. And a couple of findings from this, you know, just sort of key things to bear in mind that kind of make drone mapping projects in humanitarian situations challenging. One is the kind of irreducibility of the need for power and networking solutions, which is kind of a no-brainer, but is regularly worth kind of bearing in mind. That, you know, the equipment doesn't literally fly itself. Without kind of being able to have robust power solutions, and in our case, local area networks that were able to move data from imagery data from one machine to the next at relatively high speeds, the operations bogged down significantly. So this is sort of #1, I think. Other kind of key points are around development of communications workflows between pilots, decision makers, and data analysts. Being able to template out workflows in advance so that it was clear what was going to happen once the data came back off the drone was a sort of crucial preparedness step to be able to make this stuff work in real time during an emergency. And then airspace management was one of the, it's one of the top level issues here, so that making sure that there is a communications flow with airspace control and then with any other actors that may be flying in the same space. So as drones have become increasingly integrated into humanitarian projects, the likelihood of having multiple teams that are all flying at the same time in roughly the same area goes up. And without coordination laterally across teams, this actually becomes a safety hazard. So this is something that needs to be kind of integrated into planning going forward. So, a lot of this boils down to this idea that, whereas we think of this as a hardware kind of, flying robots kind of issue, because that's what's seen when we talk about humanitarian drones, the majority of the time spent on these projects has nothing to do with flying drones. It's a very small sliver of time. The majority of the time is actually spent sweating it out, working on, all the other parts of this process that enable the flights to happen. In fact, actually, one of the things that people routinely find when they start doing drone mapping projects is that it's actually kind of boring, because the drone, once it's in the air, does all the work, you come back, it's everything else around it. And I think this is really the core meaning of which Eric will pick up around the need for strong GIS systems, because the majority of the work is actually GIS work afterwards. Just a couple of quick resources, because regulations are so important. You can find here droneregulations.info, a global database of drone regulations by country. I strongly encourage anyone who's doing these projects to make sure you're aware of the legal regulations in the place where you want to operate. Become aware of the ways that airspace is segmented into different classes. This is from the FAA. The FAA and EU regulations tend to be picked up by most countries. And so you can find airspace designations through the regulations database and through the civil aviation departments of each country where you might be working. AirMap is an application that I strongly encourage people that are doing this work to download and install. You can use it in an app, you can use it on your laptop. It provides views into that airspace segmentation and is updated with new information as airspace management changes as you're on the ground. So it's your best resource for being able to just understand the current conditions of airspace management in your area. And ethics and best practices are key to all of this work. Through UAviators Humanitarian UAV Network, a group of experts from humanitarian agencies, academia, and the industry put together and have maintained as a living document the Humanitarian UAV Code of Conduct, which you can find at uavcode.org, around do no harm, around the need for community engagement, and a number of other kind of key issues that humanitarian responders need to be aware of when making sure that drone projects are useful in a humanitarian setting and are not themselves creating additional problems for the response effort. So at uavcode.org, you can, I strongly encourage anyone who wants to do humanitarian UAV projects to read the code and provide feedback on it if you have additional information that you'd like to be able to include. So mostly it's not about the drone. Mostly it's about the data. It's about workflows. And sorry, I didn't realize that this was still included. The workflow that we looked at was starting with flying the drone on Pix4D. So there's an application called Pix4D Capture. It's just a free app. You can download it on your phone. And then you can fly the drone in one of three formats, either for 2D maps, 3D areas, or a 3D orbit. The drone flies itself, basically, in the format that you've selected. So it's quite easy to do. You can pick it up in about 10, 15 minutes. Once you're done, drone returns home, and you have a map that can be then uploaded into GIS so that information can then be extracted from the map and used in applications that enable you to see before and after imagery, to do change detection, to do other kinds of analysis, such as what we saw with IOM in the Rohingya camps, or other projects where we're looking at damage detection. And I think this is something that Esri has been at the forefront of trying to solve for. And I think we can see a number of pretty useful workflows from Eric as we kind of get into the technical portion here. Thanks.
Great. I think we're going to move over to Eric. Eric, do you hear the slides you can share?
That is, can you see my screen?
Not quite yet.
There we are.
There we go. Thank you.
Great. Well, thank you, Andrew. Thank you, Frederick. Yeah, and I think Andrew did a really great job at showing some of that process of sweating that really goes into the whole process of flying drones in the humanitarian context. He talked a lot about some of that pre-flight process, and what I want to do for the remainder of the time here is really focus on, you've flown a drone, now what can you actually do to create an analytical product or an information product that can be used perhaps in the field as you're deploying your resources, following a disaster, or perhaps that can be used to help understand, to gain a greater insight into situation on the ground as it's unfolding. Just a real quick background on Esri for those of you who are not familiar. So we are a private company, American company, founded over 50 years ago, and we support customers basically to solve spatial problems, and this actually includes approximately 16,000 nonprofit organizations that we support through our nonprofit organization program. And GIS mapping and data visualization is really our bread and butter. It's kind of our primary focus. And we see our fundamental job is really building useful technology to help our users do their work more efficiently and better. And in this process, really address some of the larger challenges that the world is facing, and that all of us are hoping and supporting, trying to work to alleviate. So we do this with focusing on GIS, and in particular our primary platform being ArcGIS, which is really a large comprehensive platform, which I will not have too much time to go into too much detail on. But really what we think of when we think of GIS is really integrated tools that can help us from the office with our GIS projects, to the field with field operations, to spatial analytics and data science, and also to our operations centers, maybe through things like dashboards, and really thinking about GIS as more infrastructure as opposed to just its standalone system, something that can support an organization or a mission from the individual all the way through the organization. And as in addition to kind of a conventional GIS focusing on sort of raster and vector data analysis, we also kind of in the raster on the raster side of the house, we really do provide a comprehensive imagery platform that does provide, and again, thinking back on that seamless integration, creating an opportunity to analyze our imagery and create information products that we can extract from imagery, or maybe pull that imagery into other applications that we can feed into a number of different users, end users, those perhaps being in the field or the office, or perhaps an operations center. And so really ArcGIS is a scalable platform for working with all forms of imagery. Today we're talking primarily about drone imagery, but this could very well be talking about working with aerial imagery or satellite products. And really to create valuable information products that through this integrated GIS. So as Andrew has already alluded to, you know, the process of flying a drone is more comprehensive than just going out to the field. It's a process, and so as you start planning your drone projects, you begin to realize that there's a pretty common workflow that starts to emerge, and this includes tasking, collection, the processing of imagery, exploitation, and dissemination. Tasking and collection is really all about getting the proper imagery that you need, and some of what Andrew discussed with looking at flight paths, for instance, and the application of Pix4D, for instance. Processing is really the conversion of that raw imagery from the drone into a recognized geospatial content that can be used for analysis. Exploitation and dissemination is really about that delivery of information products to your end users. At Esri, we rely on drone manufacturers to provide the tools for collection. We're trending towards, through our partner network, primarily with our partners at 3DR, towards building out our tasking capabilities. And the processing step is really what I want to focus on for the remainder of this webinar. Through primarily through a software which we call Drone2Map, which here is used for creating authoritative imagery content, which for many of us is a primary goal of considering drone projects, is creating an information product that we can use, you know, following a disaster. So Drone2Map is a desktop application that turns a single frame image from drones into an orthorectified mosaic, into terrain models, and depending on the direction what we want to go, perhaps into point clouds, 3D meshes, and many more. The process typically produces 3 categories of projects, which Andrew has already touched on as well. The first being a 2D image. These are, you know, map accurate ortho photos that are stitched together into an image-based map. And you can see this here on the slide. The second is 3D elevation products, which include raster digital surface models, 3D point clouds, and 3D mesh models that can be shared later via as a PDF, for instance. And the third category is what we call smart inspection photos, which are oblique photos that can be collected that include mathematical transformation. So the end users could accurately measure lines, heights, areas, and 3D coordinate space. You can imagine doing a disaster response following an event such as a hurricane, how important that could be to be able to fully utilize that sort of 3D capabilities to measure and to assess the damage following a disaster. Just a couple key points to highlight with Drone2Map. It does support offline use. So if you are out in the field and you are processing imagery, this is an excellent product for for basically ensuring that you can monitor what you're acquiring in the field, so you don't have to return to the office and then kind of iteratively return out to the field and make sure that you're getting the appropriate coverage. Through this whole process, and what I'll show here momentarily, is we can also create reports so that we can understand the calibration of our drone and the imagery that we've collected, so that we can do that sort of on the fly in the field assessment of the products that we're creating. Drone2Map is, and I'll show here momentarily, is integrated into ArcGIS Pro and ArcGIS Online. However, it does work across additional platforms as well. So if you're not a ArcGIS user, there are still applications that you can take. If you have your image processing software of choice, you can take that product that you derive from Drone2Map and you can plug that right in. And just to kind of follow up on a couple of those key takeaways, you know, the integrated nature of the ArcGIS stack is really where the power comes. And momentarily, I'll point to some of those sort of analytical processes or steps that you could take to really turn that drone imagery into a very powerful information product or analytical product. It's a standalone application. It does not require ArcGIS. Okay, and for the remainder of the time, what I actually want to do is kind of walk through some of the imagery that we captured on that rainy day that both Frederick and Andrew discussed. While it was raining, we also sweated. And so here's a couple photos from the field you can see from our NetHope Summit workshop. And so what I want to do is actually look at some of this imagery that we captured and walk through just a very standard workflow of turning those JPEGs captured by the drone into something as impactful as a slider tool, as Andrew showed, to show maybe how in a disaster response situation, how we can create an application that we can share perhaps for our field teams, or share publicly to provide the public with a sense of what, you know, the scale of an event that just occurred. So let me here now turn to our Drone2Map interface. And so this is, when you open up Drone2Map, you'll see that you have multiple capabilities, some of which we kind of already talked through. We have the ability to after we've collected our drone data, we've brought it onto our computer. We want to we can decide on what sort of processing capabilities we're interested in. In this case, perhaps we're interested in a field processing. So we want to kind of do rapid assessment to maybe create an information product that we can share directly with our field crews, so that they can kind of maintain an eye on sort of the scale and scope of their response efforts. However, if we had some more time, and depending on the type of sensor that we had on our drone, we could also create a more comprehensive rendering of our orthomosaics, and perhaps if we had multispectral sensors, be taking additional steps to process that imagery. If we, depending on the products we're interested in, we can also process our imagery to really create those 3D products that we've kind of briefly touched on, and create a way for us to really create powerful ways of measuring before and after a disaster, perhaps you know, the effect of a storm on building footprints, for instance, and if we had some before and after imagery, how we can actually use something like 3D mapping to help us really understand the scale of the damage of an event. So as we've opened up our so in this case, what I want to do is actually publish as a 2D rapid. So we just basically are interested in taking this stack of drone images, which actually, let me pull up here to show, which we have here. You can see each individual JPEG captured the day during the NetHope Summit. You can see a few horses that were out in our field joining us for our drone session. So basically what we want to do is we want to create a mosaic out of these individual images, and process them so that they are rectified, so that we can actually use them and extract information from these images. In this case, what I want to do is actually, the step that I am walking through is just this rapid. So again, the scenario is we're out in the field, and we wanted to assess the sort of what we've captured with our drone so far. And so we're just doing a rapid processing. I've already actually done so. And so when we process our imagery, and we take those steps and we import our individual photos, you can immediately see some of that geographic information that's acquired from the drone, and that Andrew had shown in a couple of his slides as well, which is that flight information. So our flight lines, we can see in our yellow lines, and we can see each of the image, where our images that were captured from the drone. So in this case, our drone was configured to take an image every 2 seconds, and so we can see each of those individual locations where the drone captured those images. So whenever we are ready to process our imagery, we could actually go up here and we could click process. The processing speed for rapid will probably be anywhere with, in this case, we have 100 images that we brought in. I actually scaled down some of the images that we captured in the field. So with 100 images, it took about 5 minutes to process this and to create the orthomosaic. Once we've processed our imagery, we can see that instead of having those individual snapshots captured by the drone, we now have a comprehensive mosaic that really shows the coverage and extent of our flight. In this case, if we were in the field, we could easily process this imagery if we had the time, a short amount of time to bring this information into our computer, process the imagery, and then decide if we need to extend the coverage and kind of move back and forth from the field. In addition to creating the orthomosaic, we have a couple other models, digital elevation model and surface models that are included in that, that are created when we process our imagery. For instance, we have a digital terrain model that we can see here. Our digital terrain model is a model of the terrain of the Earth captured from the drone. And we also have our digital surface model, which is digital surface model is including the features that rest upon that surface of the Earth. So if we have canopy cover, which we can see here in this, what we've captured with the drone on the day in Puerto Rico, but if we also had some structures, those would also manifest in the surface model as well. While we're in the field, if we're interested in actually understanding and that sort of calibration of our drone, we can actually create a report on the fly so that we can understand exactly what that flight path looked like, what the overlap of our images and coverage looks like. And so in this case with this, the example that we're showing here, you can see that we actually, some of those sort of discrepancies in our images, in our mosaic are really likely coming from our, the lack of coverage that we have, the lack of overlap we have. And so these are really quick and rough reports that can help us make better decisions about the accuracy of our data. So we have an information product here, but we have yet to really do anything with it that, or extract any information that's valuable. And so within Drone2Map, what we can do to kind of take that first step is we can start to annotate the map. We can start to annotate our mosaic and maybe extract some features of interest. Or perhaps we can do some things like calculating area. For instance, if we're doing a damage assessment and we want to see sort of the footprint of something that is no longer standing, we can extract those features very easily or calculate those. In this case, perhaps we can use an area analysis. I clicked on the analysis toolbar, click on area, and we can actually get an idea. If we're looking at this building footprint, we can start to understand the size of that area. We can annotate it accordingly, and we can extract that information. If we had multispectral imagery, which currently we just have RGB, so we don't actually have multispectral imagery in the example here. If we had multispectral, we could also take a step to look at vegetation indices. So if we're interested in calculating things like normalized vegetation or perhaps soil moisture, we could take a step further into actually doing some remote sensing analysis on these on our captured imagery to help make decisions and inform decisions. From here, what's really important feature that I want to highlight is that sort of the analytical capabilities are extended as we move from something like Drone2Map into ArcGIS Pro. Here you can see this Open in ArcGIS Pro button. If we were to actually click it, and I'm not going to do this because I already have it open. Let's see. There we go. What we would get is we would actually immediately migrate, or that orthomosaic persists through our ArcGIS Pro. And here, what we could do within ArcGIS Pro is extend the sort of capabilities for further analysis on that imagery. So in this case, if we wanted to do some sort of object detection, automated object detection, or change detection looking at or land use classification, we could take the tools that are baked into ArcGIS Pro and really extend those capabilities from Drone2Map, and really start to move from just collecting drone imagery as simply a base map and turn it into an analytical product that can greatly inform decision making down the road. One of the other capabilities I wanted to show before we kind of turn it over for Q&A here is really extending sort of those analytical capabilities through the creation of applications, similar to the apps that Andrew referenced earlier. So we can share our imagery. If we click on our share tab, we can actually share our web maps directly to ArcGIS Online. And so here we can transform our orthomosaic, our digital surface model, digital terrain model, into feature layers that then we can actually publish online, and then create endless opportunities for shareable web applications, such as the slider app that Andrew referenced. So I've already shared. I've already clicked on the shared and processed this to my ArcGIS Online organization. So what I want to do is just show you in the remaining time what that might look like. And so this is my organization. This is our space that we maintain for our NetHope training. And what we see here is I've created a group for this webinar. And here we can see that I've actually, from our Drone2Map interface, through that sharing function, those feature layers are now shared and published online. And so we can see our orthomosaic, we can see our digital terrain model, and so forth. We can open up a web map from here that we've created on the fly from Drone2Map. And from here, we could add additional content. So if we were working in an area that we knew we had additional data that we wanted to add, we could easily create pathways to incorporate this data into our into this web map to add to or to use in addition to our drone imagery. We also have the opportunity of pulling from a number of different resources, REST APIs, a variety of different data repositories that you may have access to or that you may already use. In addition to sort of incorporating additional data sets into this web map, what we can do is we can actually share, we can go one step further and to actually start to create a web map or a web application. We can configure similar to the web application that Andrew shared. In this case, perhaps we wanted to create a usable swipe tool so that we could see before and after imagery in the case of a disaster. So we have our base imagery. We wanted to see what we captured with our drone, and we want to create a very easy to use slider tool to compare our imagery. By creating a web map, we can do so. And we can create these applications that we can then share publicly for our end users to get a sense of, to gain insights into the situation as it's unfolding following a disaster. And I actually already pre-baked an application very similar to that that Andrew shared, to where we create a very simple slider tool that we can then share out to our field crews. Perhaps in this case, following a disaster, we could share a slider with our field, our teams on the field, so that they understand, the scope and the extent of damage on the ground. And just as a final product, I do have the slider tool that Andrew configured with We Robotics configured following the flooding in 2017 in Dar es Salaam. And so we can see that we transformed our imagery product. We went one step beyond just flying a drone, or we went multiple steps beyond just flying a drone. We went from creating an imagery product. We turned that into something that can be leveraged to further enhance our decision support. And so, with that, I think that before we turn it over for Q&A, one thing I do want to leave off with, if I can find my PowerPoint. That's not it. Is that drones, the use of drones, particularly in humanitarian response, as with GIS more broadly, it does require more than technology, and I think that kind of speaks to both a message that speaks to the message that Andrew and I are trying to convey here, and wanted to use the opportunity to speak to the NetHope community about it. It does require a vision and a leadership and involvement. There is a lot more to drone projects than just simply flying a drone. And what that requires then is, a strong champion, someone who can really get in and understand the mission, understand that sort of pre-flight process, and then also understand generally the value of it. How are you going to create something that's useful in a decision-making context for your users with your drone applications? And so this does require a clear strategy, a strategy that that cuts across your costs, but also your technical support, your IT support, and the vision of your organization, and also understanding those realistic timelines. While we do provide tools that can be leveraged in the field, as Andrew alluded to, there's a lot of pre-field deployment processes that go into simply flying a drone. And so, it does require a culture of collaboration and teamwork to really help leverage the utility of both drones and GIS to really understand and seek out that full potential. and we're constantly sort of adapting our story around drones and what we now call as Esri's drone collection, and really creating an end-to-end product from the tasking all the way through analysis. So if this is something that you're interested, certainly feel free to reach out. My email is provided there. I'm happy to talk more about our drone collection or GIS applications more broadly. And I think with that, I think we can turn it over to Q&A, and we look forward to hearing to being a part of this conversation.
Fantastic. Thank you very much, Eric, and also Andrew. We got a few questions while you guys were presenting, but would encourage everybody to post additional questions in the chat window. I didn't mention how you open the chat window. If you hover over the screen, on the bottom there's a little icon that says chat. So you click on that, you get the Zoom webinar chat window, and you should be able to post your questions there. But let's just quickly go through the questions the way they came in. Andrew, there was the question about the role of We Robotics, and we were curious if We Robotics could be hired for services for NGOs when drone mapping services are required.
Yeah, so both We Robotics and the Flying Lab. So I think it's a related sort of connection. So We Robotics and various local labs have done a pretty wide range of training. We worked with a team at CRS in Haiti at one point on mapping for agriculture. We've worked with World Vision on training in Zambia. We've worked with, like I mentioned, World Food Program on a set of trainings that also engaged emergency management in the countries. And I think it's a really good idea if people are interested in kind of booting up drone projects in particular areas of interest, something that you want to kind of carry forward over some length of time to train local staff, work with local labs. We now maintain, in our case, we maintain, there's 26 labs in the network in 26 different countries, and they can all be engaged, and I can send along resources for folks if you're interested.
I think we posted the link to We Robotics out there. Maybe if you want to post something to Flying Labs, that might be useful also. So you would both, obviously you do a lot of training, but would you also take on kind of the capture information, or the recording of the flights and planning the flights, and even some of the analytics afterwards?
Yeah, definitely. I mean, I think it just depends on what is required in a particular situation. So I think that this is one of the primary reasons why the Flying Labs Network was established, to help to kind of move all of the things you just mentioned along, especially for things like humanitarian emergencies, where being there already makes a big difference. Yeah, I think it just depends on the circumstances and the kind of project that people want to implement, and I would encourage just to get in touch.
Yeah, so the next question was a little bit more around, dealing with local teams and everything. The question goes, I agree with you that localization agenda is paramount in humanitarian settings. How do you transfer those skills to local actors? Are they equipped enough, skills and equipment to use robots or drones themselves? What are the requirements in case one needs training? So
yeah, no, it's a great question. And I think one of the things that we discovered when we started kind of putting out the call for development of the lab network was that there's a pretty significant number of people all over the world, in almost every country that we've engaged in, that are already doing some kind of work. So there's a lot of variability, but drones have become pretty cheap, at least at a kind of basic level. They're relatively accessible, and there's a lot of applications already being carried out. And so what people are missing often is connection to each other, credibility with their own institutions nationally, and resources to be able to improve that work. So that's what gets plugged in to be able to identify existing local capacity and then improve it and kind of walk it up the scale in terms of the kinds of projects that could be carried out, some kind of quality control, and then networking to make sure that people are linked to one another. You know, I think, again, that's actually part of the ask, is to identify local you know, NGOs or other local actors in countries where there is no flying lab, to be able to put those partnerships together and help to kind of, you know, create that context, especially given that bringing capacity in from the outside in these cases can be slow, it can be expensive, and it can be not properly attuned to the circumstances that, you know, that enable you basically to carry out the project, like to be cultural sensitivity, language, familiarity with government regulations, things like that.
Eric, maybe you can address a little bit your capacity for local knowledge transfer or capacity building. Do you find that, you know, you have the more advanced GIS tools that are post-processing after you will capture these things? Do you have a partner network in these geographies, or would you fly people in case need be? How do you address this localization issue?
Yeah, that's a great question. So Esri is, while we are an American company, we're global. We have a global footprint. So we have a network of distributors and partner network that is global. And so we, as far as building capacity, you know, we would work with our local Esri offices or our distributors. Some of which, you know, it varies depending on place to place, but there are offerings for training opportunities internationally. Again, it kind of depends on the place, but oftentimes we look for those resources, or we partner. We extend through our additional partner networks, including the nonprofit program, with someone like, in the case of flying of drone flights, you know, I would reach out to Andrew at We Robotics and kind of see what to assess the landscape on the ground and how we can best support an organization if that is the context. So I guess to answer your question, yes. I mean, we have a global presence, and through our distributor network. And our other partner networks, we're able to provide those resources internationally.
Terrific. That's great to know. The next question that came in was Drone2Map for ArcGIS looks like a resource-intensive solution. Do you have computer specs for computing requirements?
Sure. Yeah, that's a great question, and I will say that you know, there is, as with any software, there's a bit of a learning curve to the interface. But for someone who is new to an Esri product and new to Drone2Map, I would say that it's actually incredibly easy application to develop an understanding of sort of the comprehensive nature of it. So really understanding the capabilities at your fingertips for taking full use out of with Drone2Map. As far as documentation on the system requirements, if you do go to, and I can put this in the chat, doc.arcgis.com /Drone2Map, you can actually access an extensive collection of resources and documentation to help you understand what those system requirements are, sort of more of the sort of computational requirements for running Drone2Map on your local machine, and you know, and extending that into sort of the supported imagery, you know, and any sort of supporting operating systems, and how that breaks down, and we update that regularly. So that is your best source for any Esri sort of documentation is docs.arcgis.com, and then from there you can really kind of find the tools that that are applicable to you. I will say that one thing that Esri has extensive amount of is documentation. So if you have worked with us, it's very likely that that we have been able to provide you with any documents to help answer or address your questions. So if there are any pointed questions, I certainly welcome them via email.
I bet a good Google search will probably find those resources as well. Computing capacity for ArcGIS or something like that. I'll play around with that. But if you have the specific link, that'd be great if you could put it in the window. So there was another question that came in, and that was what's the extent of the models that are built into Drone2Map, and are they all included in a standard Drone2Map subscription or license? Is it possible to import other geospatial models?
Yeah, and that's also a great question. So as far as the licensing goes, there is one license for Drone2Map. It is a premium application, which means that if which means that in oftentimes, particularly through our nonprofit program, we operate with enterprise agreements. Drone2Map is an additional license required for those. However, with that license, you do get access to the full suite of those analytical tools that are baked into, that are included in Drone2Map. And again, that the value that you get out of Drone2Map, I think, is really heightened by the connection and the integration into ArcGIS Pro and or ArcGIS Online, depending on sort of what direction you need to take your products, whether you need to do more heavy analytical work, or if you're looking to create some shareable applications. But as I mentioned before, those are not required for using Drone2Map. So if you want to leverage your other GIS software, or your imagery analysis software that's what you learned on, or that's what you like to use, those are certainly it is certainly possible to take that product from Drone2Map after you've created that orthomosaic or perhaps that three-dimensional product, and plug those into whatever you're using. As far as supported models, if I understand this correct, really the supported imagery that you would capture from a drone are JPEGs, and then your TIFFs are kind of the two primary supported imagery extensions or types. And the TIFF does, as I mentioned, we didn't show, but it could be multispectral, it can be multi-band TIFF. So if you have that infrared band, if you have thermal, all of that can be brought into Drone2Map and be processed.
Excellent. This next question you may already have answered, but I want to make sure it's completely clear. Does my license capability for ArcGIS Pro still work for the Drone2Map application, or do I have to subscribe a separate license to Drone2Map?
So it largely depends. Your ArcGIS Pro license does not directly give you access to Drone2Map, but if your organization or you perhaps bought a Drone2Map license, then you obviously have access to that. You do log in with your credentials to Drone2Map. So if your credentials are enabled with Drone2Map, if you have an organization with an administrator who allocated you Drone2Map, then your credentials would successfully log you into Drone2Map, and you can get started. If there is specific questions, about your organization and what you have available to you, feel free to shoot me an email, and we can talk directly about sort of what your organization has available.
Great. We are out of time, but I think this is a very simple question for you to answer. With that slider tool that you showed, where would you find those before images if you don't have them yourself? Can you use like satellite images?
You could bring in your own satellite imagery if you needed to, but what you saw in both the examples in Drone2Map and ArcGIS Online was our base maps that are provided to you through the product itself. So that the base imagery, the satellite imagery you saw there was just the imagery product, the imagery base map provided to you by Esri.
Fantastic. Well, thank you very much, both of you, Andrew, for your continued support with this webinar series, and Eric for a great insight today and give a little bit of deeper insight to what we captured in Puerto Rico. We were watching you in Puerto Rico, but it did get a little bit of distracting with all the rain that was coming down. So it's good to sit in a dry place today and watch what you were doing back there. So again, thank you very much, and thank you to the audience for excellent questions and interaction. And please look for an email from us pointing you to the place we're going to record the recording for this, as well as all the slides and everything. So, and if you could take a minute or so to answer that webinar satisfaction poll, that would be fantastic. So thank you all. Great session, and we'll be back with more webinars soon. Take care, everyone. Bye-bye.
Thanks, everyone. Bye.